In previous videos, I talked about direct modeling strategies and counting strategies. The main difference between these, direct modeling has a child using explicit physical representation of each quantity in the problem. However, in a counting strategy, they essentially recognize that it's not necessary to actually construct and count sets. We can count up, we can start at a number and count up instead of counting each individual thing. Although children usually use fingers with counting strategies, that doesn't distinguish a counting strategy from a direct modeling strategy. In a direct modeling strategy, the child needs to count every single object in both sets, whereas in counting problems, that's not necessary. And children's solving of these addition and subtraction problems is not limited to direct modeling and counting strategies. They can also use number facts that they learn, either inside of the classroom or outside. So let's look at a few ways we might be able to do this. 6 frogs were sitting on a lily pad. 8 more frogs joined them. How many frogs were there then? Let's suppose we have 4 different students and they all immediately answer 14. However, we want to figure out how they did this. So the first student tells us, well, they know doubles, and they know that 6 plus 6 is equal to 12. And then they know 2 more is 14. The student used the fact that they knew 6 plus 6 is 12, and they knew 8 was 2 more than that. So they were able to add the 6 plus 6, and then 2 more to get to the 8. Now let's suppose our second student. They said that they took 1 from 8 and gave it to 6. Then they knew 7 plus 7 was equal to 14. So both of these are different ways to use doubles. Children tend to learn doubles and sums of tens before other combinations, so this is a very common method to make these doubles and then adjust accordingly. My third student said that they knew 6 plus 4 is equal to 10, and 4 more is 14. So they were able to start with the 6, realize how many they needed to get to 10, and then added the additional 4 more that they needed to get to the full 8. Finally, my fourth student knew that 8 plus 2 is equal to 10, and 4 more is 14. So the previous student used the 6, added 4 to get to 10, and the second student used the 8, knew I had to use 2 more to get to 10, and then another 4 to get to the full 6. So these are all different ways we can do this, and we're not limited to just these 2 methods. These are the most common, but there are lots of other number facts that different students can either create themselves or learn either at home or in a classroom.